This is going to be a video on how to find derivatives of a function by using the definition of the derivative as a limit. Now here I have two different definitions, but I want to focus on the first one. Now also please keep in mind that this notation f prime of a means the same exact thing as these three other notations below it. So here we have the function f of x is equal to 2x squared plus 10x. We want to know what the derivative is at a equals 3, and a equals 3 implies the point 348. If we plug in 3 into here, we get 48 back. This point lies on this function. So here I have graphed the function in blue, 2x squared plus 10x, and I've also graphed a new function in orange, which is y is equal to 22x minus 18. Now, here's the point 348. A is equal to 3, which implies the point 348. What we want to do is find the slope of this orange line. That is the derivative. We're going to do that by using the definition of the derivative defined as a limit. Now the reason I've drawn that orange line is because that line is tangent at a equals 3 and the point 348 of this function. So this is the equation, y equals 22x minus 18 is the equation of the tangent line. If we just look at this right here, 22, this is the slope of the tangent line. So the answer to this problem already is 22. But I'm going to show you how to do it by using the definition of the derivative defined as a limit, where we have to first have what the derivative is before we can even get this equation. So the first thing we do is we use a definition and we take a plus h and substitute that in for x in this function here. So a is 3 and we substitute it, so we have 3 plus h substituted in for this x and this x, and we get what is in this bracket, and then we subtract f of a. So we substitute a into this function at x and this x, and when we do that we get this last bracket. Doing the algebra for all of this numerator and denominator and all the simplification, we end up with the limit as h approaches 0 of 2h plus 22. This numerator and denominator simplified is 2h plus 22. We take the limit as h approaches 0. So what that means is we let h get very, very close to 0. But it's extremely important to keep in mind it will not equal exactly 0. It's just getting close to 0. When that happens, this term here, the 2h, effectively becomes so close to 0 that we're left with 22. So we say that the limit is equal to 22. So this 22, it just simply means that it is the slope of the orange line that I've shown earlier on the graph. The orange line is tangent to this function at the point 348. Now also remember the equation of that orange line that I've shown earlier. It was y is equal to 22x minus 18. To get this equation, we usually have to do this work to get the slope, which was 22. We had the point 348, but we did not have the slope. So with the point and slope, we can use the definition of the tangent line to get the equation of the tangent line. And I'm going to show you how to do that. So to do that, all you really have to do is have a point and a slope and plug in the values into the definition. And when you do the algebra on that, you get this ending equation. Now this definition is very similar to something you may be familiar with, which is this here. Okay, it is the point slope form. So the notation here in red, it's just dealing with derivatives, so it's using different notation. So it looks a little bit different than what I have over here, but they're very similar. And all you do again is just plug in the values and you get the equation of the tangent line. Y is equal to 22x minus 18. And here, this 22 is the slope of the line, which is the same 22 right here. If you have any questions or comments, please post below, and thank you for watching.